Hey, what's up, Chem peeps? Let's do a free response practice. A student performed a laboratory experiment to determine the identity of an unknown metal. Ooh, unknown. The data table below summarizes the information collected by the student throughout the lab. Step 1. Obtain the mass of a dry, empty container. Step 2. Fill container completely with water and determine combined mass of container and water. Step 3. Empty and completely dry the container. Step 4. Place metal sample in container and determine combined mass of container and metal sample. Step 5. Fill container with metal sample completely with water and determine combined mass of container, metal sample, and water. Part A. Calculate the following. Use 1.00 grams per milliliter as the density value of water for all your calculations. Part I. What is the volume of the empty container? This first part is a little deceptive. We're asked to determine the volume, and our data table is providing us with a bunch of masses. To answer this question, what we need to know is what is the mass of the water that completely occupies the container. If we know the mass of the water that occupies the container, we can then determine the volume of that water and therefore the volume of the container using density. All right, so let's determine the mass, H2O. It's going to be equal to the mass of the container filled with water only, 116.0 grams, minus the mass of the empty container, 88.0 grams. So the mass of our H2O, calculator time, 116 minus 88, it's going to be 28.0 grams. Make sure you watch out and use correct number of significant figures. It's also important that you show simple calculations. You may be able to do this very easily in your head or on your calculator, but it's important that you show your work to get full credit. All right, now that we know the mass of the water, we're going to use the formula for density to determine the volume of water. And if we know the volume of water, we also know the volume of the empty container. The density of water is 1.00 grams per milliliter. That's equal to 28.0 grams over X. Don't even need a calculator for this. 28.0 divided by 1, 28.0 milliliters. Boom. Let's keep going. Part 2. What is the mass of the metal sample added to the container? Let's take a quick peek back at our data table. If we know the mass of the container with the metal sample only and the mass of the empty container, we can determine the mass of the metal sample. Mass of metal is equal to 166.4 grams minus 88.0 grams. Hit up our calculator. 166.4 minus 88. To correct number of significant figures, 78.4 grams. Boom. A part. I. The container with the metal sample in it was filled with water. What is the mass of the water added to the container when it also contains the metal sample? Let's go back to our data table. Again, we're given another mass value. This mass value has the mass of the container, metal sample with the water in it, and we want the mass of just the water when the metal's in there. In other words, we want to get rid of the mass of the container and the metal. And we've got that right here. All right, we've got 183.2 grams. That's the container, the metal, the water, minus 166.4 grams. That's the container and the metal. Calculator. 183.2 minus 166.4 equals 16.8 grams. Boom. Part IV. What is the volume of the water added to the container with the metal sample still in the container? All right, let's look back at the part that we just solved for. Many times in these free response questions, you'll be using the previous parts to answer the parts of the question that are later on. We know the formula for density is equal to mass over volume. We know the density for water is 1.00 grams per milliliter. We know the mass of the water when the metal sample is in that container is 16.8 grams. To determine the volume of water, 16.8 divided by 1, 16.8 milliliters. Boom. Which brings us to part B, 5. What is the density of the metal? Density, again, mass over volume. think back to some of the things that we've just solved for. We determined the mass of the metal in part II, 78.4 grams. Now we need to determine the volume of just the metal. And as we think back, we haven't solved for the volume of the metal. We solved for the volume of the empty container, and we solved for the volume of the water added to the container when the metal was in it. So to get the volume of the metal, we're going to take the volume of the container, 28.0 milliliters, and subtract the volume of the water when the metal is in the container, 16.8 milliliters. Calculator time. 28 minus 16.8. Volume of the metal, 11.2 milliliters. Calculator again, 78.4 divided by 11.2. To correct number of significant figures, our density is 7.00 grams per milliliter. Boom. Part B. Which of the following metals is most likely the identity of the unknown? Again, on the free response, look back at the earlier steps. I just solved for the density in the previous step and determined it to be 7.00 grams per milliliter. As I scan the list of metals, there is no density that's exactly 7.00, but I have one that's pretty darn close. So I'm going to identify the metal as neodymium is the identity of the metal. Boom. Part C. In step 5 of the procedure, if the student had spilled some of the water out of the container with the metal sample so that it was not completely filled before taking a mass measurement, would the calculated density of the metal sample increase, decrease, or remain the same? Mathematically justify your answer. All right, when we think about density, again, it's relating mass to volume. And let's go back to where we calculated the density of the metal. We determined the mass to be 78.4 and the volume to be 11.2. Let's think about how those measurements would change and how that would affect the density. The mass of the metal isn't going to change if we spill out some of the volume of the water. So that numerator is going to stay the same. If some of the water spills out, it's not going to be a measurement of 16.8 milliliters. If some of it spills out, the water is going to have a smaller volume. Let's say 15 milliliters. And now let's think about how we calculated the volume of the metal. We subtracted the volume of the water with the metal in that container from the volume of the empty container. If we're subtracting a smaller volume, that means our calculated volume of the metal would be larger. In this example, 28 minus 15, we would calculate the volume of our metal to be 13 milliliters. So mathematically, our density is going to decrease. Although our mass of the metal stays the same, the calculated volume is going to increase. So let's be sure to answer the question. The calculated density of the metal would decrease. A smaller measured mass of water would result in a larger calculated volume of metal. Boom. Part D. After completing the experiment as outlined above, the student cut the metal piece in half. Will the density of the cut metal pieces be smaller, larger, equal to the density of the original metal sample? Explain. Okay, let's first answer the question. The density of the cut metal pieces will be equal to the density of the original metal sample. Here comes our explanation. Density is an intensive property and will, therefore, remain constant regardless of the amount of the material present. Boom! And we're done.